Thank you so much. Thank you so much for coming along. And huge thanks to the organizers for bringing us all here. Now, the title looks so busy, but don't worry, we'll kind of slowly untangle the different pieces. My name is Sheen Brisals. I'm one of the AWS serverless heroes. And also recently I published a book along with my colleague. It's about developing serverless applications on AWS. The QR code will give you extra discount if you buy from Booktopia. I think that's Australia, New Zealand booksellers. And also later on there's a book draw to give away a few copies. So going back to my title, I think roughly 10 years ago, microservices was making the news. Sam Newman's book came out, and everyone talking about microservices. Every conference you go has to have a talk on microservices. A few years on, serverless caught up. And if you submit a talk with a serverless title, it used to get immediate acceptance. And some people like Gunnar Grosh, he's part of AWS. He used to be a hero back in those days. He's a chaos engineering specialist. So he had the trick. Every title, he would put serverless and chaos engineering. Then a single talk, he will get 2 acceptance because it's so trendy talks. I mean, these days, you know the topic, right? AI. There are conferences, there are talks. So I was actually hoping Peter or someone from the team will reach out and ask, Sheen, can you sprinkle a bit of AI in your talk? But they didn't. I even kept a placeholder, you can see on my title. The set pieces, I thought probably I could change that into AI pieces. No one reads the description, so I thought, if not artificial intelligence, I probably can say, I don't know, asynchronous infrastructure pieces or something like that. Nothing of that happened. Anyway, back here, I see smiling faces. I smile when I see people smile because genetically this is a grumpy face. Before I come to a conference, this is giving away secrets. I go to, when I come to a conference, I go to a place, hotel, etc. Before I leave the room, I stand in front of the mirror and smile. Say to my, Sheen, smile. So that's how I carry the smile to the conference. Now, here are a few people who are all on full smiles, except maybe a couple of them. So most of you should know this movie, right? Any guesses?
Mamma Mia.
Exactly, Mamma Mia, wonderful movie. Huge stars, color and location, etc., etc. But thing is, to bring this to on screen, there's so much happens behind the scene. Movie making or filmmaking is not that simple. It's a tedious process beyond the story, producer, director, writer, etc., etc. You need to think of locations, filming, and then finally bringing things together. So there's so much of hard work and complexity that goes on behind the scenes. Speaking of complexity, now it's there, right? So we can't avoid, it's a fact. It's there in everywhere, in life, in engineering, all sorts of engineering, not just software engineering. But thing is, it often creates fear among us, especially engineers. So when I speak to engineers and they pick up a new task or feature development things, they find it so complicated. They say, Sheen, why don't you give it to her? She's so good at these things. I'm not. But they're trying to run away, instead of tackling the problem. So this is a fact. Now, in software, the two types of complexities I see. One is the accumulated complexity. The second type is distributed complexity. In both cases, complexity is there, but how, where they are located differs. For example, so immediately you will say, oh, that's a monolith, I know, yes. Yes, but it may be a beautifully looking box. It doesn't need to be a monolith. It could be any software application that we build. Looks so simple and smooth outside, but internally, it can accumulate and hide the complexity. Now, if you just think this is monolith, don't worry. You just change the shape. Draw a hexagon and call it a microservice. What we do, we stuff everything inside to make it a macroservice or a lambda-lith or whatever we call. So see again, the complexity is hidden, accumulated. The other form is more popular these days, distributed complexity. Now, I showed just 3 clusters here. In a distributed architecture, you can think of tens or hundreds of these clusters, and each cluster has several microservices and applications. So if you look over, it's distributed all around, so complicated. You have no idea in an end-to-end situation where is the beginning, where is the end, because everything is distributed. But thing is, if you focus inside those little microservices pieces, you find some harmony, because if you kind of build properly, microservices are simple, single purpose, and have own boundaries and all sorts of things, right? You see simplicity internally. So that's why I often say that in accumulated, externally it's simple, but internally it can be complicated. Whereas in distributed situation, just the opposite. Externally, it looks so complicated and vast and distributed, but internally, we can find peace in the way it's been built. So how do filmmakers deal with this complexity? How do we confront complexity? There are 2 ways. One is, we can put boxing gloves on and go for fighting, smash it, what we call the Big Bang, yeah? I think the fact is, most likely we are going to hit back, the same force, because it requires a bit more careful planning and thinking in a properly orchestrated approach, coordinated with the different pieces, etc. So this gives us better way to, deal with the complexity in life and in software. So how do filmmakers confront complexity? It's simple, because if you take film, this is like the finished product, for example. So we see that as a single unit, but without us realizing, they're already breaking things down. For example, every film has an intro, title. So however they do it, it depends, but there is that separation. And then most films usually shown on theater, especially films from India, must have an interval, because they kind of write the story accordingly. So see, already kind of split. Then obviously the credits, when the credits roll, that's the final part. So a single film, as we see, has been kind of already broken into different pieces. Now, there is so in addition to this one, so within each of those the parts, you see number of scenes or sequence of scenes, right? So they're all kind of edited. So this is one way of looking at one whole film. How can we visualize into different parts? So there is a beautiful dialogue in the Mamma Mia movie. So between a man and a woman. So the pessimistic kind of saying is like, everything is complicated, nothing is simple in this life, or et cetera, et cetera. Whereas if you add a bit more optimism, then if you break things down, everything can be simple. So that is the core of this talk. So that is how, dealing with complexity or looking at complexity, way of resolving it, something we can learn from the filmmaking. So welcome to set pieces. What is a set piece? Anyone knows set piece? No, okay. So here are a few scenes from the movie. As you can see, the location or the filming aspects are all different for these 4 scenes I showed here. Not single scenes, it's a sequence of scenes. What filmmaking, what they do in most cases is that when they do the pre-planning or pre-production stage, they identify set pieces or parts of the movie they can kind of deal with in separation. Say, for example, these 4 sequences, they could have kind of scripted, planned, and shot separately, right? So this is kind of the concept they identify. I mean, things like, I don't know, a climax sequence or a car chasing or a sort of romantic scene, etc. These can be thought as set pieces, so they can kind of plan and do that, shot those things separately. So set piece is basically exactly what I said. It's a scene or a sequence of scene that requires logistical planning. And in doing so, they can plan, they can rehearse, they can kind of go to different locations and maybe even do things in parallel. So associate directors take care of certain parts where main director takes care of certain parts. Now, as you can see, there is a bit of resemblance coming to how we build software and how we deal with parts. So rehearsal is probably testing, right? So execution is how we kind of build and operate. Independently means different engineers or teams working in parallel, fulfilling the same kind of goal. So that's kind of the, the set piece idea. Now, if you look at characteristics from what I just shown, a set piece is part of a whole thing. And it requires focus when you work on a particular piece, and then obviously the planning and the testing and execution in kind of happening in parallel, and before you bring everything together. The focus is an important thing because if you take a film, that's your vision, that overall vision. Then as you work on different pieces or parts, you just focus on those things. So 2 important and essential things as we build software as well, especially when we deal with a complex piece of software development. So why is it necessary in serverless? Set pieces, by the way, is not just in films. In music also they have this concept. In theater they have this concept. Even in English football, you hear this term, set piece is often talked about. Set piece play, they say. So why do we need in serverless? It's because of the same reason. Problem decomposition is a problem with engineers. It's so difficult for many to get around building software in a systematic way. Has anyone read this book? Good, okay, a few hands up. So there is beautifully narrated by the author here. The fundamental problem, as the author say, is a problem decomposition. How can we divide a complicated problem into different pieces that can be solved independently? That's exactly, the theme of today's talk and the idea that you need to take away from here. Now, so if you bring back films, as I mentioned, that is the whole, then we divide into parts. And as I said, vision, you focus on different pieces. And that exactly is also the problem they are trying to solve by breaking down into multiple pieces. Right, so how can we bring in some of the guiding principles as we develop serverless applications so we can kind of think of making pieces and then bringing together? The 3 ways I would like to kind of, convey my idea through. First, understanding and using the serverless unique characteristics. And secondly, employing sort of proven industry patterns that helps us to think, in parts or, enable us to break down problems at different scales. And finally, think sustainability as part of the development process. You may be thinking, oh, sustainability, what is to do with software engineering? I will give you 2 different meanings to sustainability as we go along. So, serverless characteristics. I've been saying this for a while that serverless, because of some of its characteristics we'll see shortly, requires a new way of thinking. We simply cannot stuff the old way of building software onto serverless and wish for everything to be perfect. We need to change our thinking. That's why we need some kind of a mind shift to see, when we work with serverless, mostly dealing with managed cloud services and knitting them together with infrastructure code to produce value, bring value faster and to the business. And Dave Anderson, in the book, The Flywheel Effect, narrates this beautifully. Like, when you combine serverless and event-driven architecture, it allows you to iterate faster so that you can bring better value to the business faster. This is what some of the successful companies do when they adopt serverless and to make full use of the technology and its capabilities. So looking at some of the characteristics of serverless, is anyone here completely new to serverless? Today, you're here to learn. All right, good. And make use of the opportunity, because there are plenty of serverless brains here, multiple authors speaking as well as an audience, heroes or MVPs, so on and so forth. So please make use of the time today. Now, most of you must be familiar with all these kind of serverless characteristics about ephemeral, scale to zero, so on and so forth. However, you might have noticed a small shift or some of the ideas getting blurred. So serverless is kind of getting the beating a lot these days, because not everything scales down to zero. It's not just if you don't use anything, it may cost if you store data. And also, serverless containers is becoming a thing these days. You hear more and more. I'm like, come on, people haven't understood what serverless is. Now they need to understand what serverless container is. This is more like a serverless server, all right? Yeah, speak to Hater, he's here. He can talk all about what's happening in this space in AWS. But for me, though, more than the characteristics, the benefits of serverless is what attracts me. Now, if you look at all the boxes, you will find a key word in each of those boxes. So, for example, granularity, deeper security or deeper level access, managed services, iterative development, or diversity. Take, for example, diversity in engineering. What do I mean by? Because in serverless, you engineers come along to the team and they come with, JavaScript, Python, whatever knowledge. They are so good at coding. And they can knock down, Lambda function after function so quickly. Then you find they put some asterisk as the security, permission. Ask them, why? Why didn't you restrict it? Oh, I thought that's somebody else's job. Because they always used to be, the security specialists. And then they push things to the queue and pull things out. And then you say, oh, why don't you slow things down this queue? Why don't you use the parameters or characteristics of the, oh, I'm not used to it. Isn't that infrastructure engineer's job? No, it's serverless engineer's job. The same with DynamoDB. They will ask, oh, can I use DynamoDB in this company here? Yeah, go for it. And they will just make a big mess. And they say, oh, that's no SQL, because I have no SQL, I have no SQL experience, so this is so good. No, you need to understand data structure. You need so that you can put the proper access patterns so that your DynamoDB table performs beautifully, etc. So the point is, serverless engineers these days need to understand all these things. So that's exactly what I mean by the diversity. They are not just programmers. They are beyond that. They even architect applications. Now, iterative development, as you all know, it really helps to kind of push a little bit of thing there and build on from there on. So these are the core benefits of serverless that really helps to decompose and think in terms of pieces. Don't go with a big bang, full-on approach, but take things in parts and move forward. Right. So just a couple of quick examples here. So if you look at this symbol architecture, I mentioned Lambda function. It could be any kind of function as a service. It could be Azure or GCP, etc. Those three functions have different configurations. And look at the queues or the DynamoDB tables. They have different configuration. One is on-demand scaling, other one is provisioned. Same with queue. This is exactly the strength of serverless. Individuality, granularity. You can go deep down and tune each resource the way you need them. So this again brings the benefit when we think of developing in parts or in pieces. Here is another example. This is a boring looking some data pipeline. Okay? Now, you can absolutely find, you can build however you want, but just take, for example, the top part. So that's dealing with the price changes. Price changes are very critical. They need to get from where you change to the website or the page as quickly as possible. What you do, you tune those resources to perform faster. So here, you look for low latency. Whereas the bottom one, product reviews, I won't be, if my product review took a week, I won't be sad at all. So here you have the liberty to tune for, say, cost. And the middle one, maybe you can tune for sustainability. You can kind of optimize the use of resources. You use less compute power, or you use the compute power in a different hour where it's cheaper, etc. So, for example, these 3 different flows can be part of 3 different microservices. Or even within a same microservice, they can still perform the way we kind of tune. This is like, the benefits of serverless. So this is as much serverless you will get in this talk. I mean, I gave a variation of this talk a couple of months ago, and the conference organizer sent me the feedback, and someone commented, I like the talk, but there wasn't much serverless in that talk. So, yeah, we want. Right, so keep that in mind, serverless characteristics. And then proven patterns. So, for example, let's start with the organization patterns. I'm sure many of you must have read this book, right? Who has read? Okay, just a few, not many. Okay, domain-driven design, one of the iconic books. But I say this is an industry, not a book, because you might have read one of the variants of this book, like there are dozens of books written to make people understand this blue book. There are so many conferences where we pay thousands of dollars, and there are so many training courses. So what Eric Evans has given us, not just a book, the entire industry around it. Anyway, so how does it help? It helps to see our organizations as business domains. This is, again, making the pieces at a higher level, not at the sort of programming level. So the domains, your domain could be insurance, it depends on however your organization is structured. Then once you have the domains, it makes easier to identify the subdomains or the core domain. See, again, you are splitting things down to make it more kind of manageable. When you get to subdomains, then comes the interesting part. You identify the boundaries of certain things, what we call the bounded context. Because the bounded context is where a particular domain model makes sense. One bounded context is different from the other. With bounded context, it brings the boundary, okay? So when you have a boundary, we can then bring in different pattern. That is the team pattern. So team topologies. I'm not going to ask you, but you must have read this book. It has number of teams, stream-aligned teams or enabling teams, platform teams. We can make use of those different teams to kind of take care of the bounded context or the subdomains. So that's where the autonomy comes in. So for example, now we have team ownership for the boundaries. So one team, say for example a checkout team, guards the boundary. It's their product. They own it. It has its own contracts and everything. And then comes the biggie. I am sure many of you must have read this, right? So it kind of completely changed how we build systems. We started to think independent services and releasable, completely separately releasable services. Now, with all the structure you have, the split and the parts, how you kind of split the whole thing, it becomes easier to build services or applications. They live within the boundary. So see, you now kind of bringing kind of a harmony to the entire organization or entire, the software development process. So this to do with the patterns. Again, keep those things in mind. And move on to sustainability. Now, if I ask you around, you're going to give me different definitions for sustainability. I'm pretty sure most of your answers will be towards green energy, planet, environment, etc., right? That is correct. I'm not saying it's wrong. But sustainability means it's kind of a generic thing. It can be applied to anything. It is something that keeps you going with a little bit of nourishment here and there. So it can be a longer, prolonged longer, growth longer, exist longer. So hence, it's applicable to our Earth and engineering and also in life. So what we are going to look at is, of course, how in serverless development these things help. The sustainability thinking helps us to kind of build better software. So there are two things. Maintaining something is different from sustaining. So the way I kind of propose this. So if you've been through the typical waterfall traditional development, you might have experienced start with requirements and all the different siloed phases, and you get to releasing your product. What happens next? That gets pushed to kind of a maintenance mode. Nothing happens, it's almost dead. And the maintenance team is probably the most demotivated team you can find in an organization because they get no attention. Everything goes to this new shiny team. They build everything new. However, in serverless, we don't need to worry that because we have a different way of doing things. Because we ideate, we come up with an idea or a feature or something, and then we build in small iterations. We build, we operate. Then what we do? We sustain, we come back, the full circle, we take the next iteration. Typical, you must be familiar with this term, MVP, minimum viable product. What I do is, I add another MVP to it to make it most valuable product. That is your target goal. But how do you go? You go in parts, in pieces, every iteration you go through. Sustain your product, sustain your development. Right, so I usually talk about sustainability triangle. Before I show that, so if you take cloud, the cloud, not the, the nature cloud, the technology cloud. It is made of three main things. If you leave the buildings, infrastructure, and everything out, three main things. Come on, give me a name. What is the first thing, or anything, any of those three? Compute. Next. Storage. Perfect. One more. Network. Exactly. Network, compute, storage. These three things, everything is around. The thing is, each of those things require power. That's where the sustainability, the environment sustainability comes in with the cloud providers thinking how they source the energy. Right, let's look at sustainability triangle here. Now, I kind of separate into three categories, products, process, and cloud. Cloud, I just talked about. What is a sustainable product? Like I mentioned previously, it's a product that can live longer. It's not going to a maintenance mode and getting pushed out. It's kind of living it long. And for that, we need to use sustainable processes that help us build sustainable products. And then we can operate in the cloud. So in the cloud, it's a split responsibility. Cloud providers take care of certain things. We need to take care of certain things. Okay, so what is the sustainable products? How is it related to building kind of, pieces? Because of the three main characteristics: modularity, extendability, and observability. If you think of observability, it's so crucial. But think, observing activities in a pond is so simple than observing the entire ocean. That is the difference between observing a small microservices piece versus a big monolithic beast, right? So this is why the thinking that needs to bring in when we build kind of, products as pieces and how we kind of untangle the complexity. Now, processes can be several things. However, kind of it based on your development structure or team organization, et cetera, et cetera. So basically, these are the tools and methods that we use to build sustainable products and operate them in a sustainable way. Just to give you a few quick examples, like if you're thinking of the lean principles, so they give you way to reduce your value, so improve your value stream. So you reduce your wastage, and then you have the agile and pragmatic way of doing things, iterated, that we just saw, and starting small and scaling up. Then to achieve that, you need to bring in automation. That is so key. That saves so much energy and time. And that's where the DevOps principles come in. And then finally, you need to think in terms of sustaining your own teams and organizational way, how you improve or make your engineers educate and become architects. Because these days, many companies, there is no separation between an architect and engineer. They kind of all part of one team. That's how some of the teams work. So all these things part of your processes. And finally, sustainable cloud. So this is simple because cloud providers, they look after the sustainability of the cloud. This is where they think of the energy sources and reducing carbon footprint, et cetera, et cetera. Whereas we have responsibility as we build our applications, how we kind of provision resources, how long we keep them, and how we tune them. And not necessarily we tune to the maximum, we tune to the optimum, so we gain something, so that impacts, brings sustainable operation into the picture. Okay? All good? So those are the three things. So let's say, quickly before I close, a small use case where we can bring in the different thinkings together. So this is a small reward system. Some of you, most of you should be familiar. So you go to website, you have some discount or reward, you redeem, and the system kind of works with a couple of third-party applications. There's a content management system, there's a third-party system, et cetera. Now, if you're building it, you can already kind of, split it into different parts. So the domain could be e-commerce or retail, subdomain could be customer, or it could be loyalty, depending on how you kind of split up. And then you have a bounded context that is rewards. So that's our focus here. In a traditional microservices building way of doing things, what we do is we build the whole entire the rewards as a single microservice piece. That's fine. One delivery pipeline, one team, owning everything, single things. But the problem is, depending on how big the rewards, it will be a big because there will be so many elements, even though it sounds so simple. You start to ask questions like, okay, this part of the system, the business logic changes often. So that means now you are forced to change or deploy everything every time you make a change. Why do we need to do that? How do we look at the critical paths, and how do we know, how do we observe the most important pieces of this the service? And then, if you have a team of engineers, how do you make sure that they're not stepping each other's toes when they try to push into the same code base, same service? You two engineers try to deploy the same thing. And the ACL, the anti-corruption layer, how do you kind of keep your interactions with the external applications separate in a nice way? So all these things you need to think of. So this is where you think, oh, can I now look in terms of set pieces concept and identify the different pieces? Right, okay, where can we start? Let's say we can find, how do we find the core service? So for example, the backend service for us is a core service, could be a reward service. And then we think in terms of the data pipelines and flows in and out of the system. So we have a content management system outside, external. Somebody is pushing data into it. Do we need to provide something there? Maybe. So that could be a different piece. And then anti-corruption layer. So always recommended practice when you deal with third-party applications, don't pollute your data model with their data model. Put the boundary layer so that it won't corrupt your system. So you think of those things. So identify those as separate pieces. So this is how you slowly bring in the thinking. Then on top, you can have other things as well. So for example, you probably need to bring in some fraud detection mechanism. So that is an ideal piece to stay separate because it only requires the data from the main part. So it can run its machine learning and all sorts of things. And then you can think of, oh, if you need to send emails to customers or SMS and things, why do you stuck everything to the main service? Keep them separate. These are kind of away from the main action. So these things can be separate pieces. Data auditing, so on and so forth. So you bring all this sort of thinking, so you identify the different pieces to untangle from the main complicated puzzle. So that's how we build kind of set piece services in serverless. So a quick kind of, bringing everything to the box in a bounded context. So we have 4 microservices for now, right? So, but thing is, how do they communicate, right? What communicates to where, how? Let's go back to filmmaking. So let's bring 2 different scenes. And these 2 are not related, but for example, how do different scenes communicate in a movie? We all know that. Dialogue. There is a background score, music going on all the time, right? So that's how they kind of knit things together. What do we have when we have 2 microservices? Of course, come on, what do we have? How do they communicate? Event, API, messages, right? So 2 important things, communication and contract. Core of the way these kind of connecting the different pieces. So now if we go back to the diagram, we can add a bit more things. So which part is synchronous API invocation? Which part can be asynchronous or event-driven? Where we can think of async webhooks to consume events from external applications. You start adding the clarity to the whole kind of, the picture to individual pieces and how they kind of, connect together. Now, with that, so how we build microservices? So we have different pieces now, and we have different pipelines. So this is where the pure microservices thinking as per Sam's book comes in, because independently deployable service. A team of 4 or 5 engineers guarding this rewards bounded context, now they can work on different microservices in parallel without stepping on others' kind of work. So this is kind of a beautiful way of doing things. So let's bring everything in a whole, complete the whole picture, right? So we have a big bounded context, rewards, and we said we need a stream-aligned team from the teams pattern. And we have our microservices. And the microservices we identified, there are 4 microservices. But the fact is, there will be more, because there are more capabilities. I talked about emails, administration, or event sourcing, reporting, so on and so forth. It's, it's up to your system. And the team operates everything in the cloud. So they may have, 2, 3, 4 different types of accounts. It's that team that owns and operates everything in the account they own. So this is like completing the whole kind of vision of your system. So just to wrap up what we kind of looked at. So when it comes to untangling complexity or decomposing the problem, think of all the what benefits serverless brings in, the industry patterns, and then think of the event-driven architecture and how we can evolve the architecture piece by piece. These are important and crucial in modern application building. Think sustainability. Think sustainability differently. Don't just think the carbon footprint or the environment or the planet. Think sustaining the application itself. How can we keep it going longer? And finally, I leave you with this couple of quotes from this book. Has anyone read this book? Okay, few hands up. So I read this book maybe 2-3 months ago. I've been giving the set pieces talk longer before that. But I was so astonished to see the similarities in thinking in life and engineering. When we are dealing with a complex situation, we need some kind of rituals, i.e. processes and guidelines and principles to get us progress step by step. And it then finishes with this amazing quote: when confronted with big things, break it down, attack each part one by one. Thank you so much. Thank you so much for being here. Thanks, you.
Thank you, Sheen.